without further ado, I will move on to our next speaker, Sylvain Roudaut, who is currently working on the project, The Mechanization of Philosophy 1300 to 1700 in Stockholm. He recently, so just this year, published a book, La mesure de l'être, le problème de la quantification des formes au Moyen Âge. And he's interested, Sylvain, in many issues surrounding hylomorphism, matter, forms, partial and otherwise, and causation. But today he's going to talk to us about the calculatores, the use of Richard Swineshead's calculationes in 15th century natural philosophy is the title of his talk. Sylvain, the floor is yours.
Sorry, I was muted. Can you see my screen?
Yes.
Okay, great. So thanks, Clelia, for having organized this and for having me. So I'm going to talk about the book of calculations written by Richard Swineshead, and more precisely about the way this book was received in the 15th century. So what I would like to do is to show how this book was employed, mostly in natural philosophy, and more generally for what types of problems and what types of problems it was employed, and what this tells us about the way mathematics was applied in the 15th century. So here's how I'm going to proceed. So first, I say a few words about this book and its content. And after that, I will present the different types of works that made use of the calculaciones in the 15th century. Then I will present the main differences I can see between the real content of the book and the developments that we find in the 15th century. And finally, I will draw a few conclusions about what all this tells us about, well, again, how mathematics was applied to different problems in the 15th century. So first, a few words about this work. So this work has a particular status. Of course, the Book of Calculation is a very famous work, very often quoted as one of the greatest and most brilliant writings left by the so-called Oxford calculators. The book earned Richard Swineshead his nickname, the calculator, that we often find in the 15th and 16th centuries. And the book was printed several times in Italy in the late 15th and early 16th century. So it enjoyed a certain diffusion in Europe. And yet, despite all this, there are still many things we do not know about this book. So first, because even if the book is often quoted, its content remains to be studied to a large extent, and many parts of the book have not been studied in detail. Also, we still do not have a critical edition of this text. So now, thanks to recent publications, we know better well, the content of the book and the way Swineshead wrote his book, but we still do not know all his opponents, his sources. He is not the type of philosopher who likes to quote his sources. So there are still many things we don't know about the book. But maybe the most important information we lack about the calculaciones is what the book is in the first place. So there have been different interpretations of the status of this work. Some think that it belongs to the genre of sophisms. That was the dominant style of the former calculators tradition, including Hydesbury and the former calculators. But others believe that it should rather be viewed as sort of sum or a compilation of all the preceding calculators tradition. And there's also some uncertainties about its purpose. So some believe, for instance, that it was primarily intended as a textbook, but others believe that the book is way too complicated and too technical to be used as a textbook. And finally, it's not even clear that this book was really one book. And several indications in the manuscript edition suggest that the different treatises that compose the whole work might have been first different treatises, later reconstructed as one single work by the modern editors. So there's still many things we don't know about this. So to understand its reception, the content has to be presented a little bit. So the Book of Calculations, at least in the printed versions that were published during the Renaissance, the Book of Calculations is composed of 16 treatises. So the first 4 treatises are about qualities and how to measure qualities, whether alone or with other qualities in elements or mixtures. And so they form sort of consistent group of treatises. And in fact, in the 15th century, most commentaries were just about this part of the work. Treatises 5 and 6 are about quantity and how to measure quantitative change, or rarity and density. Treatises 7, 8, 9, and 10 are about reaction, the power of things, the difficulty of action, and their limits, respectively. 11 and 12 are about light. 13 is about local motion, and the 2 last treatises are about the influence of the medium and the speed of change, combining these different parameters. So at first glance, the Book of Calculations looks like a treatise of natural philosophy. You can recognize the 3 great types of motion acknowledged in the Aristotelian tradition, so alteration, quantitative change, and local motion, plus a few problems like the diffusion of light, the power of things, minima and maxima, and so on. So it looks like natural philosophy, but when one looks more closely to the content of the book, it's not entirely clear if the work should be viewed as a treatise of natural philosophy or rather as a work of logic or mathematics. It is close to logic in a sense that it looks very similar to the style and structure of sophisms, at least in most of the treatises. But it also contains a great deal of mathematics, although its style is clearly different from the Euclidean tradition. In fact, this status was already perceived as ambiguous in the 15th century when the work started to be disseminated mostly in Italy. The work is most of the time found with other works of natural philosophy or logic in the manuscripts, but at the same time, it is constantly referred to as the Book of Calculations. Its method of argumentation is often described as a mathematical method, and of course, Swineshead is always referred to as the calculator. As Swineshead himself makes explicit reference to the mathematical tradition, and he cites Euclid and Campanus a few times in particular, when he sets some principles proper to the theory of proportion. In fact, his favorite method for arguing is to show that a position that he considers as wrong either leads to a formal contradiction, so to 2 propositions P and not P, or to show that one of the few mathematical axioms he considers true is violated by a wrong hypothesis. So this ambiguous status in between mathematics, logic, and natural philosophy is precisely what makes the reception of this work so interesting to follow, because it is a telling indicator of how and to what extent mathematicians and philosophers were ready to apply mathematical analysis to natural processes. So in short, there was a great interest in this work in the 15th century, which was often quoted by many people, including authors quite alien to the calculator's tradition. We can also say that the relation of 15th century thinkers to this work is more complex and nuanced than what will be the case in the 16th century. In the 16th century, there will be a stronger gap between those who defend this philosophical style and those who reject it. In the 15th century, it is not unusual to see philosophers and scientists generally opposed to Swineshead views employ some of his concepts for some purpose. So the uses of Swineshead's text were of different kinds. And in fact, we we can divide into three groups the types of text in which Swinesed's calculaciones appear. So first, explicit commentaries to the works or parts of it, like Philippus Aiuta, Cristoforo de Recanato, Giovanni Marliani, who has a short question on locomotion. Indirect commentaries, so works that do not present themselves as well, explicit commentaries, but which are so close to the calculaciones that we could consider them as commentaries to a certain extent. This class includes the question left by Hieronymus Picus at the end of the 15th century, or the parts of the Summa Naturalium of Paul of Venice, for instance. And finally, a third class of text with scattered references to the book in works that are not commentaries at all. And here the list is very, very long. Gaiden of Tien, James of Jacobus of Forli, and well, the list is actually pretty long. So, so as you can see, Swineshead was quite a famous name in the 15th century. So the first thing that we can note is that Swineshead is not only quoted by logicians or pure philosophers, so to speak, but also by physicians and scientists. And this is the first interesting observation we can make. The mathematical techniques said by Swineshead in the calculations are employed in quite concrete problems by scientists who are not really interested in logical or sophismatic aspect of the work. Maybe the clearest example of this is Giovanni Marliani, who was a physician active in the mid-15th century. Marliani was trained in North Italy and is mostly famous for having worked on phenomena related to heat. He's also known for having engaged with Gaetan of Tien, so Paul of Venice's student, on the problem of on a controversy about reaction, problem of reaction. What's interesting is that both Gaetan of Tien and Giovanni Marliani use the calculaciones in the same way, namely by employing the concept originating in Swineshead of a multitude of form or multitude of quality. This concept can be found in the treatises 7 and 8 of the calculaciones. It is a concept by which Swineshead aims to quantify the power of a thing. So in other words, a concept intended to measure how much a body can act on another body. By the time Swineshead was composing the calculaciones in the 1340s, the will to quantify qualities was not uncommon at all in natural philosophy, as Daniel has reminded us earlier. The term quantity of quality, for instance, was pretty common, and it was commonly used to refer to the total amount of quality if you consider both its intensity or its degree of intensity and its extension on a surface. The notion of quantity of quality was also used in medical context, in which case it was slightly different, referring more to the amount of quality if you take into account the weight of medicines. But in the calculaciones, the concept of multitude of quality was intended to include all these parameters. So to measure the power of a thing, so what a thing can do, one needs to take into account what Swineshead called the multitude of quality, which depends on the intensity of a quality, its extension in the body, and on the density, the material density of this body. The insistence on these three parameters is what is really original in Swinesed's quantification of power. And this probably explains why it chooses another term, so multitude, rather than quantity to refer to this magnitude. But Swinesed's point in the calculaciones was mostly to underline the importance of density when it comes to measuring power or capacity. And most importantly, Swineshead did not set any rule for converting the multitude of quality into another multitude. What I mean by that is that Swineshead does not explicitly treat these multitudes as quantities that you can add, multiply, or divide in in a sort of extensional way. But that's how Gaetanov-Tien and most of all Marigliani use this concept. In fact, this notion is probably the most common definition of how to measure the power of something in the 15th century. You have that in Paul of Venice, and you have that in Aquilini, Pomponazzi. But the most practical uses of this concept are to be found in Marigliani. Marigliani explains that given a quality like hotness in a substance having a certain multitude, if you divide the extension of this quality by 2, you will get half of the multitude. But the same goes for intensity and density. If you keep the same extension and same density and multiply the intensity by 2, you will get a multitude of hotness 2 times greater. And you will have a multitude twice greater if you multiply density by 2. So this may seem trivial at first glance, but actually it's not. It's one thing to say that the power of a thing depends on different parameters, but it's an entirely different thing to say that these parameters may be compounded or divided in a purely extensional way. No matter if you multiply the intensity or density, if you multiply it by 2, you will get the same total amount of power. This seems, of course, to violate the prohibition of metabasis, according to which you can't predicate, compare, or compound magnitudes of different orders. But Marigliani, and to a certain extent Gaetanov-Tien, use the notion of multitude to quantify the capacity of things and to formulate concrete rules describing the behavior of natural bodies. For instance, the speed at which water is heated by some hot iron, for instance, or the speed at which the water will revert to its natural state. This approach to the calculaciones as applied mathematics is also clear from the way Italian philosophers select the precise passages that are relevant for empirical problems, mostly. For instance, as far as I can see, and sorry, Daniel, but I will leave aside what you have in Albertus Thomas and in the circle of John Mayer. In the Italian context, very few of them are really interested in the study of convergent series that we have in different parts of the book. Even in the parts of the book that enjoy the broadest diffusion, so the first parts of the book. In treatise 2, for instance, Swineshead takes a body divided like this into an infinity of proportional parts, each part of the body having 1 degree more intense than the previous greater part. Swineshead demonstrates that if we take into account the extension of the quality together with its degree, the total overall value of the body will be 2, which amounts to calculating the sum of this series. What's interesting is the way Swineshead gets to this result by piling up, so to speak, by imagination, the parts of the qualities, almost like a graphical method. Now, it does not explicitly ask the reader to do this, but it's pretty clear when you read the text that it has some sort of graphical intuition in mind. And you find in mid-15th century commentaries like that of Philippe Aiuta figures like this, so diagrams which actually will be taken up in the printed editions of the Calculaciones. But most commentators do not even mention this quite interesting result. Most of the time, they prefer to use the most concrete problems dealt with in the book of calculations, like the problem of reaction, for instance. It is quite interesting to note that Swineshead is often cited as the most radical opponent to the view that reaction is possible, something obviously in total contradiction, not only with Aristotle, but also with the most common observations. Swineshead believes that if you take seriously the Aristotelian principle, according to which the force of an agent must be greater than the force of a patient for an action to happen, you will never be able to explain why two bodies having opposite qualities of the same force can act one on the other. So these two bodies will keep the same temperature, for instance, in this example. Now in the calculaciones, this gives rise to very interesting developments about decreasing series of ratios which tend infinitely toward the ratio of equality, where there is no action. But these arguments are left aside, and people like Paul of Venice and Gaetano Tien focus rather on the empirical explanations provided by Swineshead for explaining why there's actually no reaction. It seems like there's a reaction, but there is no reaction. He has an interesting story about that. So here, the most complex mathematical developments of the calculaciones are left aside. And it seems to me that it's difficult to find anyone before Alvarez Thomas who really engages in the problem of series, convergent series. But the reception of the book of calculations also shows a clear reluctance towards certain ways of applying the theory of proportions and mathematics in general to precise topics. This is particularly clear in the discussions over elements and mixtures, which are obviously very often discussed in the 15th century, still heavily dominated by Aristotle's physics. In the calculaciones, this corresponds to parts 3 and 4. So in part 3, Swineshead studies how we should measure the value of an element having two unequal qualities. And in part 4, Swineshead explains how we should measure the value of a mixture having different elements. For instance, if we take a fire having hotness at degree 8 and dryness at degree 2, how should we measure the intensity of this fire compared to another fire having only dryness at degree 1, for instance? So what value should we attribute to this fire, and how should we calculate it? Should we say that it's 8 or 5 or 4 or something different, and why? On this point, the reception of calculaciones generated much disagreement. In the first decade of the 15th century, Paul of Venice follows closely the plan of the calculaciones in his Summa Naturalium. He accepts the conclusion of the first two theses of the calculaciones about how to measure single qualities, but he rejects Swinehead's position when it comes to the elements. Swineshead believed that in the case of an element like this fire, one should take the mean proportional degree as reference for measuring the body. Paul shows that this view leads to contradictions and that one should rather take the maximum value, so 8 in this case. But he accepts nonetheless one of Swinehead's idea concerning the measure of mixtures having opposite qualities. So like in book 4 of the Calculaciones. He follows Swinehead's claim that we have good reasons to take into account both the extension of qualities and their intensity in order to calculate the total value of this body. So this body here would be hot as degree 2 in this example. Right, so the detail of the discussion is not very important actually, but what's definitely interesting here is that Paul of Venice at the beginning of the 15th century really believes that it makes sense to compound or subtract two values corresponding to different qualities like dryness or hotness or coldness. So qualities belonging to different species. Of course, it is far from obvious that this really makes sense and that we can attribute a real reference to this number when we say that the body is 4, for instance. And there seems to have been a growing concern about the real meaning of such calculations, in particular in the Italian context where the manuscripts of the Calculaciones were mainly available. The point was not that mathematical techniques in general should not be applied to natural processes, motions, lights, or qualities, but the point was more that the result of some operations does not seem to have any reference outside the mind in the world. You have this concern very clearly expressed by Aquilini in one of his writings. I won't read this passage, but in short, Aquilini's point is pretty straightforward. Aquilini says that you can't just compute one number from two numbers referring to different things, because the operation you perform on two numbers has to refer to something real and to two things having sharing something in common. So sharing something, yeah, sharing something in reality outside the mind. And Aquilini is not alone on this point, and you find similar claims in Pomponazzi, for instance. So it's maybe not a mere coincidence that the next and last phase of reception of calculaciones in the circle of John Mayer at the beginning of the 16th century witnessed certain disinterest in calculating the value of mixtures. Anyway, and so I come to last point I wanted to mention, and which is one of the most characteristic features of the way the calculations were received in this period. The discussions about the ontological implications of the calculations and conventions of measure that are chosen by Swineshead. If we take into consideration all the direct and indirect commentaries on the text, the very large majority of these writings are about the first 4 treatises, and most of the time about the 2 first treatises, which are about the convention for measuring equality. This is the case, for instance, for the longest commentary we have on the first book, written by Cristoforo de Recaneto, which is almost entirely in Treatise 1. The same goes for the commentary of Hieronymus Picus, Domenico Grimani, and the treatise left by Pomponazzi. All these treatises share the same concern with the real meaning of the convention of measurements chosen by Swineshead and their ontological implications. In the first treatise of the book, Swineshead intends to find a sound convention for calling equality hot to a certain degree, for instance. And therefore, he seeks a convention for applying the theory of proportions for comparing qualities. So let's take a scale of 8 degrees, for instance. And let's say that degree 8, in this case, represents the highest or maximum degree. And the other extreme here is the non-degree. We like to say the 0 degree, but we shouldn't do that for some reasons. Let's take a hotness of degree 4, for instance. Well, we can say that something is hot at degree 4, that there is no problem about that. But the problems start when you take into consideration another quality like quality B, which is hot degree 8, and when you want to compare those 2 qualities. Swineshead's convention consists in saying that the intensity of a quality must be measured by taking the distance to the non-degree as point of reference for the proportion between the 2 qualities. So in this case, quality A is twice more intense than B because it is twice more distant to the non-degree. Of course, you could choose another convention and take the other extreme term as reference for applying the concept of proportion. So you could take, for instance, the maximum degree here. But in this case, you will get another ratio between the 2 qualities. Indeed, if you choose the other term as a reference for calculating the ratio between these 2 values, you will get the result that the ratio between A and B is less than 2:1, because it is less than half the distance toward the maximum degree. So only degree quality C here, which is at degree 5, would be half distance between them. So only degree C would be twice more instance than B. And of course, the same question arises for the notion of attenuation and how you can compare 2 qualities as to their attenuation. So should we take the maximal term or the minimal one for calling something remitted or attenuated? And on this point, Swineshead believed that we should also take the minimal term in this case for calling something remitted, because Swineshead's point was that attenuation is not a real property. It is a mere privation of intensity, and also because it makes computations more easier, actually. But what's interesting about Treatise 1 is that Swineshead has to consider quite a weird consequence due to its convention, namely that a maximally hot quality will also be attenuated. This consequence follows from the convention chosen by Swineshead, because if we say that attenuation is a privative property with respect to intensity, then when the degree of intensity is maximal, the degree of attenuation should also be minimal. So let's say attenuation is represented by the blue line here. So in order to reach the minimal degree of attenuation, the blue line must be divided an infinite number of times. But since the degree of attenuation is inversely proportional to the degree of intensity, the degree of intensity should be infinite when the non-degree of attenuation is reached. But in normal condition, when a piece of iron is maximally hot, for instance, it is very, very hot, but it's not infinitely hot, of course. So Swineshead has this paradoxical conclusion that a maximally hot quality is in fact attenuated. Now, Swineshead mainly concedes that conclusion because it arises from the perspective of sort of logical sophisms, and it doesn't really worry about it. But the attitude of 15th century commentators on this treatise is generally very different. Hieronymus Picus, for instance, expresses a real concern on this point, even if he finally endorses Swinehead's view. But Domenico Grimani, toward the end of the 15th century, plainly rejects this view and claims that it does not make any sense from an ontological point of view. Grimani's point is that if you decide that two predicates refer to one and the same thing, taken positively and privatively, you should not arrive at the conclusion that one maximum is different from the other minimum. Besides, Grimani says that the reference for measuring something cannot be a non-degree or nothingness. It has to be something real or something like a positive unit. Pomponazzi also rejects this view from metaphysical analysis. Pomponazzi will claim that you need a real ground for measuring something. In the case of measure using numbers, the numbers have to refer to something, and this something has to be some sort of perfection outside the mind. And so if attenuation refers to imperfection, so the lack of perfection, you can take that as a basis for measuring something, because you can take nothingness for a unit of measure. Now, this sounds like abstract metaphysics, and maybe with some Platonist tone, but in fact, this view was pretty common, and not only in Pomponazzi or Grimani. And I think this is quite telling, and that indicates at least two things. First, it indicates that the Calculaciones were still considered as an important text in the late 15th century in Italy, but also that the mathematical techniques were conditioned by stronger requirements as to their ontological basis for applying the theory of proportions to different objects. It also shows that the lack of proper units of measure for calculating natural properties started to be regarded as a real problem, and that taking the non-degree or absence of something for calculating a ratio may be good, maybe for sophisms, but not for clearly not for a more empirical approach to physics. So a few conclusions about these brief remarks concerning the reception and use of the calculations in the 15th century, mostly in Italy. So first, purely historical remark, the 15th century witnessed an intense and continuous tradition of study, debates, and developments of the Book of Calculations, from Paul of Venice to Pomponazzi. Second conclusion, this case study suggests that the so-called decline of the calculated tradition at the beginning of the 16th century is probably not only due to the institutional or even political reasons usually put forward. It probably also stems from some internal evolution of this tradition and the way the mathematics of the Calculaciones was applied to natural philosophy. not because natural philosophers of this period were reluctant to apply mathematics to describe nature. Quite the contrary. Precisely because of this and because of the internal limitations of this method and its lack of scientific relevance. I mean, internal limitations when it comes to offering some relevant way to apply the theory of proportions to qualities like heat, for instance, where there is no units of measure available. Or lack of scientific relevance when the calculations performed by Swineshead do not have any clear reference in the world. In the case of the multitude of quality, the term invented by Sport, the expression invented by Swineshead was very useful and could serve for differentiating what we would nowadays call heat and temperature, for instance. But in the case of the numerical values attributed to an element having different qualities, it was actually quite hard to see what was the exact meaning of these numbers and calculations. So maybe one lesson to be learned from these few remarks on the reception of calculaciones in 15th century Italy is another indication that the usual story about the origins of modern science should be definitely revised, in the sense that modern science wasn't born when natural philosophers started to apply more and more mathematics to nature and to physical processes, but rather when they started to limit its domain of application and started to restrict it to better defined objects. Thank you very, very much for your attention.
Thank you very much, Sylvain, for this really, really interesting description, both of Swineshead's treatise and its reception in the 15th century. I'm sure that there will be questions.